Let's go ahead and finish up the first part of lesson 65 where we're talking about these different trig equations where our job is to solve for the theta or the angle that we have in the question. We just saw in the first set of questions that we have to be careful when we're doing an exponent on both sides of the question because sometimes it does give us an extra answer that's really not true. We noted that square roots were always positive, which means then the first ratio had to be positive as well, and there's only two quadrants where things are positive for the different ratios that we have in our Cartesian plane. Now, the second kind of question that we're going to have actually isn't going to have a radical that we have to square to get rid of it. It's going to have some parentheses already set up for us in the question. I'll show you what we're going to do. So what we're going to have to be careful with this time is that problems that have tangent, cotangent, secant, and secant sometimes as well can give us those spurious or those extra roots. Remember the definition of tangent in the Cartesian plane is y over x. Well, if like my answer is 90 degrees, well, on the 90-degree axis, we have the ordered pair 0, 1. So if I were to put that into my question and it says tangent 90 degrees, well, that means I have y over x or 1 over 0. Well, I can't have a 0 in the denominator, which means then my answer would not be allowed to be 90 degrees, and I would have to eliminate that from my list of final answers. We'll see that show up in our next example that I'd like to walk through with you here. So notice the question says we're going to solve given that our x, so I use x this time instead of theta because the book's going to do that as well, our x has to fall between 0 and 2 pi. Now remember pi, that's your radian measurement. Pi is the same thing as 180 degrees, so that's the same notation as saying 0 degrees up to 360 degrees. So here's our question. Tangent of x minus root 3 times sine x plus 1 is equal to 0. Notice this question has been set up as a multiplication problem for us. That question was already equal to 0, and that's important when it comes to this kind of question. When I have a multiplication question that equals 0, well then what has to be true? One of the parts that I was multiplying together has to be equal to 0. So that means either my first parenthesis, where I see tangent x minus root 3, has to be equal to 0, or the second parenthesis that I see, sine x plus 1 is equal to 0. So remember in our questions, we kind of looked at a shortcut, and this is the next line where I have the shortcut. Tangent x equals root 3 is the opposite of what I saw in the parentheses. If you don't remember that, then you write it out like I've shown on the screen, and then you add over the root 3 to continue. Well, I'm now going to pick the x. I see that tangent is positive. Where is tangent positive on my Cartesian plane? Is positive in quadrant 1, and it's also positive in quadrant number 3. So I'm going to need a first quadrant and a third quadrant answer for this first part of my question. Looking at the triangles, is there an angle that has a tangent of root 3? There is. The angle that has a tangent of root 3 is my 60-degree angle. 60 degrees is in the first quadrant, so that's my first possibility in the question. Now, the second answer that we said, it was in the third quadrant. Well, how do I get into the third quadrant? I rotate past 180 degrees. So 180 plus 60 gave me my second answer of 240. Now, remember this question says to give the answer in the radian format. So to go from degrees to radians, we multiply by pi over 180, because pi is the same thing as 180 degrees. So 60 times pi over 180 gave me pi over 3, and then 240 times pi over 180 gave me 4 pi over 3. Now, switching to our second equation, sine x plus 1 is equal to 0. That was the second parenthesis. The second parenthesis could also be where the 0 is sitting. If I start to solve that equation, I would subtract my 1 over, and notice that's the opposite of what was in the parenthesis. So sine x equals negative 1. Well, where is sine negative? Sine's negative in quadrants 3 and 4. However, I don't have a triangle that has a sine that's going to give me the answer of 1. So that means I need to rotate into the Cartesian plane. Well, what's my definition of sine in the Cartesian plane? Y over r. Remember in the Cartesian plane, r was always equal to 1. So what has to be true about this y in the numerator? If I need the final answer to be negative 1, the y also has to be negative 1. Where on the Cartesian plane do I see y is negative 1 at 270 degrees in our problem? Now, Here's where we got to be careful because my answers have to meet the original requirements. You really don't have to check anything when it comes to sine and cosine because sine and cosine always are going to give you an answer. It's just this tangent idea that we can't use. So in the triangle, like on the first part of the question, well, that was the tangent question. So those two answers over there of pi over 3 and 4 pi over 3 work. It's the ones that I got to worry about from the Cartesian plane. Do those answers still work when it came to a tangent question? Well, 270. 270 was the axis that was headed down, and that was the ordered pair 0, comma, -1. My definition of tangent is y over x. So that means my fraction would say -1 over 0. Can I have a 0 in the denominator? I can't. So even though the answer of 270 came from the sine part of our question, it would have to go in for both of those x's on the original question, and it can't go next to the tangent, so I have to eliminate my answer of 270 degrees, and I would only be able to give the first two answers that I got of that pi over 3 and 4 pi over 3. So please make sure as you're working through these questions in your textbook, watch out if you have a tangent, and the same thing is true for the reciprocals of your secant, cosecant, and cotangent, do they actually work? If you're in the triangle, you should be okay because you don't have any zeros within the triangle, but in the Cartesian plane, you do have some zeros, so you got to be careful that there's not a 0 in your denominator. So as you're working through these questions, if you run into one, you get stuck, go ahead and send me an email or Skype with me, and I'd be glad to help you or help explain the question to you.